Hello friends, today we will see the derivation for the centripetal acceleration using calculus method. So, first see the diagram. Suppose a particle moves to point P whose coordinates are x and y. The position can be denoted by a position vector r. Let the angular displacement covered by the particle be theta. So our vector can be written as xi cap plus yj cap. And further we can write it as r cos theta I cap plus r sin theta j cap. Since our vector can be resolute to two components r cos theta and y sin theta. Now, theta by time gives omega, which is the angular velocity. Further we can write it as theta equals to omega t. Hence our vector becomes r cos omega t I cap plus r sin omega t j cap. Let this be equation 1. Now let's differentiate both sides of equation 1 with respect to time. We will get dr vector by dt equals d of r cos omega t I cap plus r sin omega t j cap by dt. This gives d of r cos omega t I cap by dt plus d of r sin omega t j cap by dt. Further, taking r as it is constant here, we get this equation. Let's see how we get this now. D by dt of cos omega t equals d by d omega of cos omega t into d omega dt of t. Using chain rule similarly for d dt of sin omega t. Now double differentiating equation 1. Hence the final equation gives us minus omega square into r cos omega t I cap plus r sin omega t j cap. Replacing this underlined term by r vector from first equation, we get minus omega square r vector. Hence the modulus will give the acceleration for centripetal, that is equal to omega square r. So force acting on the particle with mass m will be m omega square r. Replacing omega by v by r, we get centripetal force equal to mv square by r. This much force is necessary in opposite direction to keep the body from central seek. This anti-centripetal force is nothing but centrifugal force.